This is 5-7, the Pythagorean theorem. According to triangle sum theorem, this measure of this angle would be 30 degrees because we need to add these up to 180 degrees. So since they're all acute, this is an acute triangle. To classify by angles for the one on the right, that would be a right triangle, and if you wanted to, you could even figure out that missing angle. Okay, to simplify 2 radical 3 squared, keep in mind it's the 2 squared times the radical 3 squared, because the squared is going to both since it's in parentheses. Well, 2 squared is 4, and radical 3 times radical 3 is radical 9, but the square root of 9 is 3. When you multiply radical by itself, the radical just cancels. The square root and the square cancel. So you get 3. So 4 times 3, which is 12. If you don't type this in your calculator properly using the parentheses, the calculator won't help you on something like that. Okay, A is 6, B is 7, C is 12, find A squared plus B squared plus C squared. Whenever we replace a variable, we're supposed to do this with parentheses. It would make a difference if the number was negative. Your calculator won't calculate it correctly. Find A squared plus B squared and find C squared. Which value is greater? Well, A squared plus B squared, 36 plus 49, versus 12 squared, which is 144. 50, 86, we have 85 versus 144. So the greater one would be 144. Find the value of x, give your answer in simplest radical form. So I have to remind you guys how to simplify radicals. That was an algebra skill. So Pythagorean theorem would be a squared plus b squared equals c squared. We use this for right triangles. And so the legs are your a and b. It doesn't matter which one's which. And x, this hypotenuse, the x in this case, is hypotenuse is across from the right angle, and that's always going to be your c value. The hypotenuse is the c. The other ones don't matter, so I could do like 6 squared plus 2 squared equals x squared. Well, 6 squared is 36 plus 4 equals x squared. 40 equals x squared. To get rid of the squared, we square root to cross that squared out. And so we have radical 40. Well, we can't leave our answer this way. We have to simplify it. So the way that we simplify a radical is you can do a factor tree on it. Like 4 times 10, 2 times 2 is 4, and 10 is 2 times 5. And you take out a pair, and the pair of 2's gets put on the outside. The pairs outside, the leftovers get multiplied and put back inside. Another way you can think of this is if you have 40, radical 40, you know it breaks down to 4 and 10. Well, I know the square root of 4. The square root of 4 is 2. So that's another option. Okay, for example B, it would be x minus 2 squared plus 4 squared. So a squared plus b squared equals, my hypotenuse is the x, so equals x squared. Now x minus 2 squared, that's FOIL. This right here is FOIL. It's x minus 2 times x minus 2 plus 4 squared, which is 16, equals x squared. So to FOIL, you do first x times x, which is x squared, outer x times negative 2, which is negative 2x, and I'll do inner, negative 2 times x is negative 2x, and last, negative 2 times negative 2, positive 4. Plus 16 equals x squared. Combine like terms, x squared minus 4x plus 4 plus, sorry, I can do the 4 and the 16, so plus 20 is equal to x squared. Subtract x squared from both sides, and I get those cancel now, so now I have negative 4x plus 20 equals 0. Subtract 20 from both sides. I get negative 4x equals negative 20. Divide both sides by negative 4. X equals 5. Oops. So 5 minus 2, so this side's 3. and the other one's 5. And I can check that to make sure. So if I just do a squared plus b squared equals c squared, you get 9 plus 16 equals 25. So that's correct. So some algebra skills that we need to remember here. 2 of them. So if you need help, you want to come see me. We have got simplify radicals and multiplying quadratics, which is FOIL. So you can try these 2 problems and pause the video when you're ready. I'll give you the answers. So the one that you probably had more trouble with would have been example B. In example B, we have to make sure that we are foiling the x minus 1 squared. And so the other thing is when we subtract the x squared, they cancel and we get x equals 13, but keep in mind that you can check your work. That's going to be crucial for these to make sure you didn't make a small calculation error. So in this next problem, I would draw out our picture frame. And when it says that we have a ratio of the length to the width to be 3 to 1, this would be 3x and 1x. Because if we dilate that, it could be 6 to 2 or 9 to 3 as measurements. So when we have the ratio of length to width, we do 3x. I should do 3x the other way actually. 3x and 1x. And then the diagonal is 12 centimeters. How wide should the frame be? Round to the nearest tenth. So they're wondering what the 1x, the x should be. We're going to round to the nearest tenth. So this is going to be, since it's a rectangle, we know there's a right angle right there. We're going to do a squared, because we could put that 1x right here. So x squared plus 3x squared needs to be in parentheses. A squared plus b squared equals c squared. So x squared plus, remember to distribute that power, so it's 3 squared, which is 9, x squared equals 144. So then I get x squared plus 9x squared is 10x squared equals 144. Divide both sides by 10. We get x squared equals 14.4, and square root to cancel that exponent, and x equals about 3.8 centimeters. So in some of the examples already, we had some Pythagorean triples. Those are common legs and hypotenuses for right triangles, and so it saves a lot of time for something like the SATs. Instead of having to calculate this, I have these triples memorized. So find the missing side length, tell if the side lengths form a Pythagorean triple. So a Pythagorean triple, for instance, we'd have, like, if you think of this as 7 and 24, because I divided both by 2, then this should be 50 without doing too much math, because I know it's 7, 24, 25 triangle, and I'm doubling everything here, so 25 doubled is 50. So another way you could do this is, we didn't know the hypotenuse, so we put x squared there. 14 squared is 196 plus 2304 equals x squared. $2,500 equals x squared. So now we're going to square each side, and we get 50. To make sure we answer the question, find the missing side length. I did that. Tell if it's a Pythagorean triple. Yes, because it's a multiple, sorry, gotta think of the word, a multiple of all 3 of those in the triple. Okay, so here we have a 4 and a 12. We can divide both of these by 4, so that might help. I would get a 1 and a 3. Nope, it's not ringing a bell in terms of a Pythagorean triple. So let me just go ahead and use a squared plus b squared equals c squared. The 12 is my c, that's the hypotenuse. So it's going to be 4 squared plus b squared equals 12 squared. 16 plus b squared equals 144. Subtract 16 from both sides. b squared equals 128, and so we square root both sides to get b isolated, and we end up with, you have to simplify that 128, so you can do a factor tree like 4 and 32, and 32 is 4 and 8, and 8 is 4 and 2, and I notice this, the square root of all these 4's are 2, so it's 2 times 2 times 2, which is 8 radical 2. 8 radical 2, and so it's not a Pythagorean triple. We didn't end up with the whole number there. I'm going to pause the video here. You can try these if you want and hit play when you're ready to see the answers. So the converse of the Pythagorean theorem is saying that if a squared plus b squared equals c squared, then we know that it must be a right triangle. And the Pythagorean inequalities theorem states that if c squared is greater than a squared plus b squared, then ABC is an obtuse triangle. And if c squared is less than a squared plus b squared, then the triangle ABC is an acute triangle. We're considering c as the length of the longest side. So in this next problem, I would consider 10 to be c and 17 to be c. And so we're used to doing a squared plus b squared equals c squared, but in these ones you have to remember to put c first. So c squared, we're trying to see what it is compared to 5 squared plus 7 squared. So we get 100, and here we have 25 plus 49. Well, 100 is greater than 25 plus 49. So therefore, since it's greater than, c squared is greater than, this is going to be an obtuse triangle. And to see if the side lengths work as a triangle, remember we do like 5 plus 7 is greater than 10. 7 plus 10 is greater than 5. And 10 plus 5 is greater than 7. And these are all true, so it does meet the requirements of a triangle. And then we're classifying it as obtuse, an obtuse triangle. So again, to check if this next one's a triangle, we do 5 plus 8 is greater than 17. 8 plus 17 is greater than 5. And 5 plus 17 is greater than 8. So I can already tell on this one that since 5 plus 8 is not greater than 17, that these can't form a triangle. So it's not a triangle, so therefore then I can't classify it either. Okay, let's start with, it says tell if the measures can be given, can be the side length of a triangle. So remember we do 5.8 plus 9.3, and we're trying to see if that's greater than 15.6, which is not true. So these cannot be the side lengths of a triangle. Do the same thing for the next one. So 8 plus 11 is greater than 13, that's true. 8 plus 13 is greater than 11, that's true. And 11 plus 13 is greater than 8, and that's true. So this can be a triangle. And if so, classify the triangles as acute, obtuse, or right. So in order to do that, we take our c squared. Remember, our c is the largest number, so 13 squared. And we're trying to compare that to a squared plus b squared. So 169 compared to 64 plus 121. What's greater than, less than 121. So it's 169 compared to 184, which is less than. Since it's less than, this is an acute triangle.